Start streaming. Okay, cool. I should advertise. Okay, this jazz is really getting on my nerves, bro. Okay, let's advertise. Somehow open Discord. Doxing myself. And of course we're gonna open there. What did I do? What did I do? Okay. Thumbnail is not it, bro. Okay, quit Discord. We just finished advertising. Okay, cool. So, this is a beautiful thumbnail, but we should click off and, oh wow, would you look at that? I already got everything set up for us. So, where did we leave off? It's a very good question. Very, very good question. Okay, I like rearranged my desk earlier, and it's like not it. So, give me a second. Also, I got like my webcam is actually just my phone with Video Ninja up there, and it's like the tripod is like on the table. Like. I swear if I say like again, I'm actually gonna. Now. Hello, bro. Oh my gosh, bro. No shot. Brad, long time no see. Long time no see. Hi, Felipe. Okay, did we leave off in a working thing? Yes, we did. Yeah, and then I was testing out the limits here. So P6 is not going to exist, so we can just like kill it. Alright, so where did we leave off? We left off with something, but it's also kind of like buns. If you direct your attention to this goofy little thing right here, this is our memory. Well, it's actually what our memory would have looked like. Actually, not really, but you know, just imagine. These hashes are like used memory, so this is allocated. Someone wants it. These equals are not used memory, but like they were used and then they were cleared. So there's like two types of non-used memory in this system, and I don't know if it's a good idea to do this, but there's this memory right here, which is just like null, like there's nothing here, it's never been used before. And there's this memory which has been used and just been cleared. Yeah, once again, this just means there's one byte here, and then this has just been cleared. You can see this reflects it because we got the big little 43 right here. I should probably like zoom in actually. Okay, so we got the big 43 right here. Okay, this is a very awkward zoom for some reason. So as you can see, we got the big 43 right here. And then this is going to be pretty much all of this. I'm not going to count it out, but I think that's 43. And yeah, we just clear it afterwards. Obviously, we got the number 1 here. Like this just reflects what this is. Like the P, which is the first pointer, is this 2. As you can see, there's 2 here. Now the P2, there's 5, and there's 5 here because we make it and then we clear it right over here, so it becomes the equal signs. And then P3 is this, which is 1, and then we do a P4, and then we clear it again. So yeah, pretty cool. Now, there's a lot of issues with this. First of all, you should have noticed it's very fragmented. So what does that mean? That means that, look at this. Right now, what the program will do is it will start, and we can actually just check this, honestly. If we just make another, like, P5. Like 4. Remember, this is 1 right here. So right over here, it's 1. So if we do this, yeah, you can see like there's 4 more. It adds on to like the end. But hold on, we have 5 spaces here, so that's an issue. There's always gonna be fragments, right? But even if like we did make a system where this would just fill up and there's be like 1 empty here, and then you're still like fragmenting things, because if you want to get like a I don't know, like 10 byte memory, 10 byte block of memory, you can't just put it here. Well, we're imagining that this is like full, or like even like if we don't even have to imagine. I mean, we got like a 5 empty slot here. This is you can't fit anything over a 5 byte. What do you call it? Allocation there. So it's gonna have to start here, and then if you clear this, it's good. Like it just gets really messy, really fast. So yeah, we tried doing this like weird math last time, and it was like not only is it like really sketchy, it's also like I feel like it's gonna be really slow. Because like right now we have a size of what, 64, I think, no, 128. Our max heap size is just basically what we ask from the computer. Hold on, my microphone is really loud. Basically, it's what we ask from the computer. We oh my gosh, bro, I'm struggling here. Look, in a regular memory allocator, I'm pretty sure. Well, no, I'm pretty sure. I'm sure that what they do is when they need more memory, they just ask the OS for more memory, like with mmap or something, like a function does that. Right now, we're just given a static memory, so when the program starts, it only has like a certain amount of memory to deal out. Obviously, I'm gonna make it work with mmap, or I don't know if it's mmap on Linux. I know that it's probably on Windows, which is basically a function that asks your operating system, "Hey, give me more memory," and yeah. And then from there, you can make your own memory allocator, because just asking for memory, it's not really, like, not the same. Because you gotta actually handle it. Yeah, you're watching my live playing War Thunder, nice. It's crazy, bro. You still play War Thunder? Okay, new things that I want to do. So, this is gonna be very slow. So look. In C, I notice a lot. The thing with C is you can either have very memory efficient programs, or you can have CPU efficient programs. You can't really have both. Well, I mean, you can have both, but you can't have like a extremely, what do you call it? Not optimized. Well, I guess optimized. You can have optimization and efficiency sound the same. You can have an extremely efficient CPU and extremely efficient RAM program. That much, okay? Like for example, it's seen with like Pragma Pack, for example, which takes these structs and instead of optimizing it for the CPU by making sure that each section is, well, just like as an explanation, it basically by default makes structs just have empty space in memory, but it's structured in a way that the CPU can very easily read it without wasting cycles. That's like uses more memory, obviously, because you have empty space in memory. So you can use something like Pragma Pack. Like if I do something like this, look, Pragma Pack, like that would work, but then we use more CPU cycles, we save memory. You know, it's like the same little game of do you want to waste CPU or memory. So this is the exact same thing that's happening here. It's a lot more noticeable right now because right now we are working with static memory, and hold on, this will make sense in a second, but like right now we need a lot of different lists, so you can see, or like arrays, I guess. So you can see like all these arrays, and each one of them adds the exact same number of memory. Well, we got 2 arrays here, I can't lie to you. There's gonna be more later. So each of these adds, so 128 bytes times 2, and then if I want to make like another one, it'll be times 3, times 4. And these arrays, they help a lot, right? Because they allow you to do, like, I'll explain this a bit more in detail later, but what we're going to be doing today. But allows you to save a lot of CPU cycles by saving data in the arrays about the memories. So like metadata or whatever. So right now, the reason it's more clear that this takes more memory, well, it's not really clear. If I'm being totally real with you, like, you won't notice this. It's 128 bytes. I mean, we got gigabytes of memory. I got like 32 gigabytes in my system, I think. Well, I don't think I know. So this is not really noticeable, but if you want to, like, if I set this to, like, I don't know, this much, which is what, like, 128 kilobytes, it's not even noticeable. Like, this much, that's 128 megabytes of memory. So now it's going to be a bit more noticeable, because instead of 120 megabytes, we're going to be doing 256 megabytes because of this. So it's more noticeable now. The reason it's more noticeable now is because I have to make these arrays the same exact size, because I don't know if the user is going to allocate 1 byte 128 million times, or the user is going to allocate 128 million bytes one time, right? So I have to have, like, I don't know. I just thought in my head a contingency plan. I don't know if that's like the right way to put it, but like, I have to make sure the program can do these things. And since we're not dynamically allocated with like mmap or something, and we're static, we're limited by static size, I have to do this. So later, this is going to be much less noticeable, because like, I'll just allocate how much I need from like the operating system. If that made no sense, I'm sorry. So basically what we're doing is we're just going to be, as my previous example from RAM versus CPU usage, we're just going to be focusing on CPU. So we're going to make it faster. Yeah. But it's going to take a bit more RAM. And I think that's fine, honestly. I don't think it's that deep. Okay, so first of all, I want to redo this. So I'm just going to like save this. And then I'm going to kind of like rearrange things. First of all, this struct is pointing right now to a start and an end. Also, I guess this kind of makes no sense for it to be void, because this is not user, I guess, touched or manipulated. So we already know it's gonna be a char. So this points to a place in the heap. So I don't know, like, say the start is here. Well, I mean, this is literally how it works, and the end is here. Cool feature, but still it's susceptible to fragmentation, because we can't easily move it. If I want to move this over here, guess what I gotta do? For every single one of these hashes or the bytes, I gotta change their metadata to say it starts here and ends here. Do you know how annoying that is? If you have like 1,000 of these, that's gonna take a lot of CPU cycles. So what I'm gonna do, it's very simple. Instead of pointing directly, I'm gonna obfuscate it. I don't know, like, that word probably is right? So we're gonna have a double pointer. So it's gonna point to a pointer that's gonna point to a place here. So I can always, well, okay, let me try to explain this, why this is useful. So I could draw it, but I don't really want to. Basically, I'm trying to visually explain it. This is gonna be really bad, because I'm not like, it's really like, if you don't understand pointers and see like that well, it's gonna be a bit confusing. But basically, a pointer just points to something. So if I just were to zoom in, hello, that's the zoom. Okay, so right now, the start and end right here. The start points to this place. The end points to this place, right? It just points somewhere. It's not that deep. So if I were to change this, if I want to make it like go here, replace with this, I have to go through every single one of these, and I have to change the start to be this and the end to be this. So that's really, really, really slow, because I got to update every single pointer so it points here instead of here for the start, here instead of here for the end. I could use a pointer to a pointer. A pointer to a pointer will point. Okay, oh boy, this is gonna be hard to explain. Okay, it will point to a pointer. In case you couldn't tell, which basically means that the one pointer will point somewhere here, like wherever placed this, like, I don't know, whichever one. A pointer to a pointer will point to something pointing to this. why is this like confusing thing useful for us? Well, it's really simple, because instead of updating every single one, right, a pointer, 2.0 point something, I think. Yeah. Oh my gosh, I forgot to enable my chat. Sorry. Select live sources and yep, activate selected. Okay, my bad. Oh yeah, there you go. So it will, instead of, okay, let me give you a different example. Right now, imagine asking a friend, where does this start? And your friend instantly tells you it's right here. Okay? Pointer to a pointer is like a friend asking a friend, where does this start? And that friend asks another friend, hey, where does this start? So instead of going through every single friend here, right? And telling them to make sure it starts here, we can go to the second friend and say, make sure it starts here. So we only do it once. And since all these 5 friends ask the second friend, which there's only one of, we don't have to go through it 5 times. We only have to tell one person, because each of those people, each of your friends, each of your first friends, so 5 of those friends, are always going to ask the second friend. So it's always going to be talking to the second friend, right? So we only have to do one change. I don't know if that makes sense. It just works well. Just trust me, bro. This will help us a lot with just... Wait, I'm just thinking, because I had an idea to do something else with double pointers. This might just solve it. Yeah, honestly, we could just solve fragmentation or defragmentation. We can implement it with just this. So this goes to a char. This goes to a char. Should I make him unsigned? Actually, I'm just thinking. I should. Also, I'm just gonna zoom out a little bit. Unsigned just basically means just give me a byte, pretty much. And then, sorry, buddy, we're gonna be double pointers. So heap metadata, I mean, yeah, that's gonna stay. And then it's gonna be heap pointers. So it's an array of pointers. Yeah, that checks out. Okay, so I'm just thinking, how am I gonna do this? Because this heap, it's like organized. You see how it starts here and has everything like organized and whatnot, and we can have empty space here. Are we gonna play it the same way with this heap? I don't know. We'll see. So if we go back to our Malloc function, which is right here, actually. Oh, well, I guess we gotta figure out how to play it now, because this is exactly where it is. It's got a bunch of errors here, but whatever. Okay, I'm actually gonna rename this to mem Alloc. And yeah, so you just need a certain size. Sorry, I'm just thinking out how to do this. Also, my royalty-free, copyright-free jazz in the background is a little quiet. I'm gonna lose all my audience retention real soon. Okay, how do we do this? We do... So right now we have a pointer which points to heap plus heap size, just the offset, so that's fine. But no, that's fine. That is fine. No, it's not fine. Okay, so remember I don't know if anyone remembers. I said that we might have another array, and how this might be solving our issues, our defragmentation problem. Well, or our fragmentation problem. Defragmentation is a solution to the problem. Well, this is it here. We still have to update the pointers of the person. Okay, and then this is actually a bit not complicated, but okay, we'll need another one. Basically, what we're doing now is for every single. Okay, I might have to draw this. Not even gonna lie. No, I broke my computer last time. I don't know why. I'm not gonna do that. Okay, it's gonna be hard to explain. But right now, what you get from the Malloc function is you get a pointer to where your memory is at a certain like location. Right? So basically it just tells you like if I call Malloc, which is right here, and this is a pointer, so like point to me where this memory is so I can access it. Pretty cool. The problem with that is we can't really defragment, or like we can't really move things around because the user owns the pointer. I can't really go in and access this and change it every single time. You gotta move this 5 slots to the left, right? It's still gonna point to this start, but it's just gonna be empty. So guess what? Double pointer save us again. My idea is to basically get the memory address of this, which is what pointer is. It's memory address. That's how it points to things, and store it somewhere. So we can always go in to this memory address and change it around, per se. Make it point somewhere else. So let's do that. Oh my gosh, my cat wants to play. Heap pointers. Okay, this is where it gets really difficult because of something called, I actually have to use my brain. Yo, okay, my cat is actually screaming, bro. Yo, like I'm streaming right now, bro. Yeah, I know. Anyways, back to this. This gets really difficult because I actually like use my brain for this, and it's kind of hard to do that. Okay, so we got the pointer. So I'm just gonna I'm gonna start commenting. It's a pretty good habit to get into. I have another project for a custom file size I did earlier, and not earlier, I did that like a month ago, and so much comments. It was so beautiful. So heap the simulated for the heap array itself, heap pointers that point to each array of pointers that point to okay, yeah, Charlie, like, what do you want? You want to play? I'm streaming right now, bro, please. Sorry, my cat. Here, like, I don't know, you can play like next to the table or something. The point to each allocated to each pointer made by Malloc location. Oh, is that not a word? Dang, too bad, I don't care. That's crazy, right? Like that like the C compiler is literally just gonna yeah, I can't really say that. It's gonna commit Sudoku after that. I mean, if I heard that from the programmer, I would just stop working. Okay, back. It's not even C compiler's fault. This is the IDE's fault that it's like. Okay, what's the right way to say it? Oh, you're not gonna tell me. Wow, Perfect. Heap metadata pointers. Array of pointers that point to each star. Whoa, 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 whoa. And end point for the metadata. Array of metadata. Okay. You notice I'm just doing anything by starting work? This is an issue, I think. No. Wait, yes, it is. No. No, it's not. Okay, it just points to a pointer. It's not that deep. Okay. Yeah, that's fine. Oh, why is my stream lagging? I mean, here it says here I don't have excellent connection, but according to my YouTube, never mind. Back to this. So first we make a pointer just to the actual heap itself. That's fine. Then we make a pointer to... So pointer to heap. Then make a pointer to heap pointers, yeah. So how do we do this? It's just gonna be the memory address of the pointer to heap. Okay, seems legit. So there's gonna be heap pointers plus size. Okay, what do you mean by heap size? Oh. Heap size. And we should dereference that. Is equal to the memory address of pointers to heap. What's your issue? It's crazy. You're nor a void pointer to a pointer. Or. Okay, what? Is implicitly converted to incompatible pointer type. Is it? No. What, you got an issue now? Oh, no, we gotta do this. Wait, do we have to do this? Yo, what are we even doing, bro? Unsigned char pointer. Instead of dereferencing it, just like it's one level down. Pretty cool. Metadata temp. Okay. Yeah, this actually takes brain power, if you believe it or not. So the metadata temp is gonna be... I guess the metadata itself. What did I do? Unsigned char? Oh, do you believe it or not? Wait, why didn't we do this from the start? I guess I really like the word void. So just, it's a pointer. We need a double pointer because... why does life have to be so difficult? So let's go to our heap metadata pointers, and then it's a pointer. Heap metadata pointers. Oh, we haven't figured out how we're gonna play this. Okay, maybe we do something like... To be honest with you, I'll just keep track of it. Let's just go like linearly. Plus heap metadata size. It's gonna be equal to... Oh, and your pointer to heap. It's a redundant cast as well. What does this mean? I don't know. We should also make it so you can have a size 0. I feel like that's not really. Or if size under or equals to 0, then also it's a bad combination. Back to this. Okay, like the thing is I don't really get what I'm doing right now, so I should probably I kind of half get it, but at the same time like on autopilot I don't really get what I'm doing. So we got this pretty self-explanatory, just it's a heap pointer. It do be like that. And then right here we got heap metadata plus metadata size, and we should probably do increment this. And then right here, I guess. Oh gee, are we serious right now? I guess just this. Start equals this plus size. No. Okay. Yeah, that's fine. Then I guess we're just gonna do +1, and then since size zeros are not even it, so we're just gonna wait. What am I doing? Oh yeah. Okay, so sorry, I just had a complete brain fart. Size zeros are not gonna be in here, so we can do something called ignore them, and we can just do this. +1 is equal to point to heap plus size. Yeah. And then heap metadata. Oh no. I did everything correct. Heap metadata plus size. No, not plus size, but rather +1. Okay. That works. What about you, sir? What are you doing here? Heap metadata. Plus heap size. Yep. Is equal to this. Okay, that seems legit. Sure. I'll give you that. Oh, we don't have a pointer to heap. Pointer to heap, maybe. Oh, and we don't have a pointer. We have a pointer to heap. Sorry, I'm just confusing myself. I can either talk well or I can code well. I can't do both. Okay, so that's legit. Oh, yeah, you're not gonna be working now. Okay, string copy should be fine. Hope. And the heap metadata. Oh. This is not gonna work right now. So let's see. First of all, let's fix this. This is a really useful function. Very simple but useful. So heap metadata plus char unsigned. That's it? Okay. Sure. Yes, so. The free function. Oh boy. Okay, so this is very cool, but we have to redo this. Now, how can we do this? No, this does not work. Sorry, sir. This is actually a pointer to a pointer that points to an unsigned char. So, you gotta like bucko. Which means that, my gosh, this is so difficult. I'm just thinking of edge cases when this is next to. This is barely even an edge case. This is an actual case. You know, I'm just thinking, like life would be a lot easier if you just made this null. Like everything null. But okay. This was our issue last time. So sorry, I'm just thinking myself. If this plus 1, right? Plus 1, I don't know, bro. It checks if this is an end thingy. So if this plus 1, I guess it's not really a good example, but if this plus 1 is equal to this null, like, you know, whatever, not allocated stuff, then it's gonna, like, whatchamacallit, it's gonna reduce the heap size. So, like, it's just, hold on. Oh, I should probably not have this just, like, here, because next time I'm gonna go to test my computer, just like, blow up. Okay, interesting. Sorry, once again, I don't know, I'm so tired, I just woke up. Okay, let's see. Back here. We got, so this is, yeah, this is legit. Oh, no, that's what I was looking for. So heap size plus size is over max size. Well, guess what? It's actually -1 because of something called, sorry, it do be like that. That's what it's called. This means that this should not give me an error before. Last time it gave me an error. I'm not gonna go back to that time, but just if you had like a 128 size and you're allocated a 128, or like not a 128, like you allocated just like a 1 more than the actual size, it'll let you do it, and then you get a segmentation fault or like sig sev or whatever. I don't know what that is. Not good. It's not good. Hello, Iggy2. How are you doing? Okay, anyways, back to this. Let's just get it over with the freedom thing. Like, free. Okay, first of all, we're gonna do mem-free. Bro, I just woke up, like, legitimately. Mem-free. Let's get a void pointer. Okay, well, our current setup, let's just speak of it from a higher level, consists of a heap, a pointer to each point in a heap, metadata, and a pointer to where it starts and ends. So, not a bad setup, right? This means, what do we have to do? Well, to free things, well, we gotta do something called freeing, right? No. So, we have to... Awkward silence. Yeah. So what we have to do is, first of all, you have to, well, we don't have to clear the things. Like, actually, like, that's, like, not really our job. It can be, there's gonna be garbage information on it left. That's fine. We have to, sorry, move the heap pointer or whatever, like, the heap size. I'm thinking of a stack pointer or heap pointer or whatever. Move the stack size down. We have to get rid of everything there. What do you call that? Crap. What am I even saying? We have to get rid of the metadata. So we have to, like, give it back to the free area. we have to then defragment. Okay, defragmentation, that's not our job. Clearing and giving back to the free area, that's our job. That's where it gets to our job. Defragmentation is going to be in this really cool function called defragment, which we'll just call from inside of free. Okay, I'm just going to clear all of this. It's not even useful anymore. So, what do we have to do first? We have to clear the metadata. So, in theory, all we care about is clearing the metadata. The data itself is going to be garbage. I don't really care about that, if I'm being totally honest with you. We don't have to zero it out. There's no point of zeroing it out. There's like other functions, like we can make a memcalloc, right, to clear it if we really want to zero it out, or we can, gee, I don't know, like there's no point. It's just extra CPU cycles. So it's really just the metadata we care about. If there is not, just two simple checks. So metadata cleaning. If there is no cleared areas behind or in front, make your own clear area metadata. If there is a clear area behind or in front, merge with it. Very simple rules, right? If I were to clear this, there is not anything behind it, but in front of it, there's clear area. So we're just going to merge to a big one. If I were to clear something over here, there's nothing around me, so I'm just going to, well, what do you call it? Make my own. So same thing that happened here. This was set. There was a 5 set here. And it got rid, so it just made its own clear area. Very simple, very, very simple rules. That's literally all that the free function is going to do. Defragmentation is going to be handled by the defragmentation function, no duh. Okay, so what do we have to do? We have to check if there's clear areas behind or in front of us. The way we're going to do it, we have to go to the start and end pointers. You have to check if there's something to the left or something to the right. So the thing is, our metadata has something called a flag. It's basically a byte that tells you what, like, just tells you about it. If it's a 0, it means it's a clear area. If it's a 1, it means it's not a clear area. It might add something more in the future, it might not, right? Okay, hold on, let me stretch. Okay, so let's check. We have to do, we're going to do a char is clear. Is next to clear. It's going to be equal to 0. So now let's actually do the checks here. Which is going to be very simple. Right? Probably. So we have a void pointer. First of all, we got to do a check first. So let's comment. First, check if the pointer points to the clear. Oh, points to the start. What am I saying? Points to the start of the metadata. Else error / return / refuse. So first I'll do that. Notice how I did not even type that and just typed it for me. That's like marvelous. I mean, awesome. Okay, first we gotta do heap metadata. So metadata heap. So the data is gonna be metadata. So pointer to heap to metadata pointer. Oh yeah, sorry, my bad. So it gives you the reference to it. Oh boy, we got triple pointers now. Yo. Oh, this is so difficult. I'm not even joking. Okay, it's not really difficult actually. So we're gonna check if pointer is the same as data start. Wait, we're dereferencing it, so the start. And there we go. Data start. Then, oh, if it doesn't equal, printf. And then we're gonna do return, which is a I'm not gonna say that word. The first check. Okay, I'm not gonna say preliminary, like whatever check. I can't pronounce that. So now we have to do something, a little something, and that something is gonna be checking if we're next to a clear. If dereference data that's start -1 is equal to -1. Oh. Does this not work? What? Oh, I guess heap to metadata pointer -1 pointer -1 start. Wait. No. Thought flag is going to be equal to 0. Or I guess I could do it differently, but I don't want to. If this is equal to 0 and oh no, we actually do this equal to 1 and that's going to be different because we have to do pointer end. So that's going to be a pointer, which is going to point to a pointer. And then we're going to do heap to metadata pointer. I'm using recursion. Not really recursion now, is it? Flag. So dereferencing the end. Oh, and +1. It's equal to 1. Wait, no, or, right? 1, 2, 1, 2, 1, 2, 1. I know it's the same thing, but I just want to like double check. Okay. Or, my gosh. Then we're gonna check. Okay, let's just check if this is less. So, if and then else. Okay, so pretty simple here. What do we do? We merge. The way we merge, okay, we have to first of all set all of our flags to 0. Now that I think about it, we could do something with the flag. Like, okay, I'm not gonna look. It's gonna use a bit of CPU cycles, but I don't really care if I'm being totally honest with you. for I get. Hold on. First of all, I'm just looking here. I just need to double check something. This is legit. So this has to dereference it first, right? No. It has to do this. Okay, I guess that just has precedent. Okay, int I equals 0. I is under what? Is that going to be under heap to metadata pointer? We have one up there. No. No, yeah, we do. So data and dereference and minus data start. So yeah. And then I plus plus. What we're going to do is we're going to change the flag now. So first of all, wait, how are we going to do this? So the flag is simple, yes. But okay, the flag is simple. Let's just do the flag then, if it's so simple. So pointer. Keep track at a pointer plus I. Flag is equal to 0. Well, I guess we should do this. Okay, and over here we're gonna do data of start. So it's a pointer to a pointer is gonna be the same as start. And we're gonna do the exact same here. This is the exact same thing here. This will eventually defragment our or fragment our other function. It's so annoying, bro. But it do be like that sometimes. Okay, I don't care. For now, let's just do this. Let's fix it later. So, yeah. Whoa, hold on. No. Actually, guess what? The end is going to be our end. And there we go. Maybe we should do this first, actually. Should we do this first? No. It's fine. Okay, well, I mean, I don't see anything. Wrong with this. It should work, technically. And then let's do U. So it's going to this. So the data that start is going to be equal to U of start, and then U of end is going to be equal to end. And then you're just going to be Pretty simple, I would say. So that clears the data. But this is only the case that you're not making your own. And that case is actually much simpler. Because all you do is just set your metadata everywhere to be this one. So for int I equals 0, just exactly this, right? But you're gonna do heaped metadata pointer plus. Kind of noticing this is not an I, but you know, that's fine. I is actually equal to, oh, no. Yeah, flag is just going to be equal to 0. We don't have to do any, like, anything else. That's it. Hypothetically speaking, that should really just be it. So let's make you a lot simpler. We got P. Will you throw me an error? No, you won't. Okay. P2 should look a 6. Yes. And then let's do memfree P. It's my work. It's my work, guys. Nuh-uh. What do you mean, nuh-uh? Okay. Okay, we don't have to draw the heap metadata. It's fine. Draw heap data is a bit. I'm more concerned about this. So, it's just a flag. What do we not? Pointer doesn't even do it. Back in like this. Should be. Unless I mess something up here. It's really possible. Keep my data pointers. Placement and that size. Pointer to heap, which is this. I don't see how I messed it up. But I'm being honest with you. I don't see how that's messed up, like been messed up. It's pointer to pointer. We dereferenced it once. Boom. So that's just a pointer to like whatever. Bro, what do you mean now? Like, bro, what? Okay, what if we did not have the check? Oh boy, this is scary. Segmentation. Oh, bro. Yeah, called it. Okay, so this check is really important, I guess. Yeah, I mean, I guess. I got no clue, to be honest with you. Could trying to debug this work? I don't know. We could try to debug it, I guess. What is this like? This? Step. What? Okay, I don't know what that was about, but sure. So chart email, I like. Okay, sure. That checks out. If okay, we get it, bro. Oh, first we're gonna print. Now let's print. Oh. Don't know if that should be the same. I mean, I know that it should be the same. That's not that. I'm just like, don't think that shouldn't be the same. Why is this different? Oh, we gotta dereference it first. Yeah, my bad. So we are the same. So this current point, should be fine. So, like, the issue was, what was the issue? They were not the same, which means that go here. Where's our free function? Oh, it's right here. I forgot to change the names. The pointer doesn't equal to, and we get the pointer to heap returned. Okay. So does not equal to dereference data start. Okay. This is dereference data start. So heap metadata pointers plus heap metadata size. But we dereference it, right? Yes, we do. So let's dereference them. Yes. And then also print pointer to heap. Why is it different? Why? Why are you different? You shouldn't be different at all. So now let's go back here. And check why. So pointer to heap is just heap plus heap size. So heap metadata pointers plus heap metadata size is equal to pointer to heap. Yeah. That's how it goes. So why is it different? Right? Why are you like, I don't get this. Maybe I'm not seeing something, but like, this shouldn't be different. Oh, just in general, why is it like this? It should not be like that. We already increment. Speaking of which, by the way, I'm gonna do this. And I'm just gonna get rid of these. And then at the very end, we can keep metadata size plus equals 2. So let's try that actually. Whatever. So yeah. Yep. Sir. Okay. So. Okay. Now let's print out pointer to heap. Legit. Now we're gonna do heap metadata pointers plus heap metadata size. Oh yeah. Oh, okay, that works now. Okay, that's legit now. Okay, so you are not gonna be mad at me, right? So you're gonna continue to work. Yep. So let's see. Okay, that seems legit. Why don't you free it then? Oh my gosh, bro. It works, but also doesn't work. Like it functions now. There's like radius. Okay, it functions. Okay, so like okay, this first thing functions. We never use this variable. And well, I mean, you know what? We have a very cool thing called a debugger right here. So let's P2 Malloc. Mem free. This is where it gets interesting and juicy. Oh no. Okay, that's legit. That's legit. Okay, never mind. That's just for heap to metadata pointer. Can you hack the Area 51? Probably no, bro. This isn't hacking. This is just programming. It's just debugging. Actually, it's a really cool debugger though. I really like this. Is next to clear 0 pointless char. Okay. So yeah, that's good. Data start. First, let's print data start. And let's print this thing. Okay, so they're different by 1 byte. Oh, she's like, I guess legit. Yeah, it's legit. So, yeah. Yeah. Data start is now equal to this. Sure, that it works. If it ain't broke, don't fix it, right? And you do this. So now we're gonna do print data end. And I'm going to assume that's the exact same thing here. Yay, that works. Okay, Charlie. Yes. So, from here. Yo. Okay, yeah, we can move now. Uh-huh. From here, do we really check that? Oh, hold on. This is 63. And we're removing P1. P, sorry. Right? Okay, what's your issue, bro? Did my cat type something? Okay, whatever. Yeah, it's just an open bracket somewhere. I like a miss semicolon. So, as far as I can tell, it's legit. So we're moving P, which means there's going to be to the right. Yes. Okay, that's legit. That's legit. That's legit. That's legit. So we're doing good work right now. So I don't get why. Whoa, 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 whoa. What? Is that so? How big is this? 2. Should have been at least 2 runs. This is run. This is run. Is it run? It seems like it's run. And start. Oh, yes. It's because it's like tainted already. We already changed it. What's happening? Yeah, I missed something. Where is this? I missed like it's like an open bracket or something. Where is it? Else, no. Really? Yeah, it's the else. Okay. Okay, that makes so much more sense now. Look at that. It works. It works. Oh my gosh, so much work to get to the same theme where we started. The same place where we started. But this time we can make it a defragment function. Okay, I don't need you for now. So thank you for your service. Debugging session. We're gonna do like 46, and then we're gonna do like P2 free. So if we do this, yes, that works. Now we're gonna make a defragment function. It's gonna be very simple. It's gonna take no parameters at all. Goodbye. And we call it mem defragment. This is where it gets fun and interesting. I hope, at the very least, it does. Now, this memory function is still going to be very susceptible to not being good. So, after a while, it will kick the bucket eventually because we're just moving the fragmentation somewhere else. Back, like, it's, to explain it very simply, we're basically, we have to like also have safeguards for this. Well, not really safeguards, it just has to be like different methods of storing apart from arrays, because that's, whoa, oh, someone's calling me, hold on. I gotta put my camera back. My bad. Okay, we're back. Oh, a little bit of delay. That's fine. Whatever. Okay, delay is stopped. Now, what are we doing? What were we doing again? Oh yes, we're gonna do something called mem defragment. Very nice. So, okay, bro, I'm actually gonna crash out, bro. Try look. Yes, very nice. Unfortunately, sorry. Let's go back to this. Okay, how do we defragment memory now? It's a lot simpler now. So the way we're gonna, okay, yeah, bro, can we not like jump back? Okay, so we're gonna have to go. Oh my gosh, bro. Oh yes. Where? Yo, I'm actually gonna crash out, bro. I'm not even joking. If you jump one more time, I'm gonna crash out. Okay. Hello, hi guys. We've been streaming for an hour, roughly. Anyways, we've made good progress. What are we? Yo. Okay, yes, you can be here, but like be here. If you go next to my keyboard, like, sorry, my cat's just like terrorizing me. Okay, let's continue this. So what's the best way to do this? Is it just to My barber did me dirty. No, I'm just growing out my hair. I know it's not really the best, but I'm gonna get it cut like soon, probably, and then it's gonna look fire again. You know, I'm doing webcam again because it might attract more viewers, but inherently not. Okay, look, my cat is actually kind of like I'm actually about to crash out, bro. Can we stop trying to throw everything off the table? Now, back to this. You get it, guys? Because like it's like the sea garbage collecting. Tough crowd, right? No. Okay, so we're gonna go back to the memory defragment. Look, hi guy. Look what we've done. It works. It like if I can make memory and then 4, 5, and then we can have like 16 and 6, 7, and then we can free P5, and then what? 6, 7, yeah. Too funny, man. Why is this like this? Oh, cause I'm doing too much. I'm taking too much. 25. Boom. There we go. And you can see it's like freeze it and unfreeze it. Like no, it's like allocates it and freeze it. Now we're just making a defragment, so this gets defragmented. Very cool. So how do we do this? We're gonna have to go through every single metadata. And then we're gonna jump ahead. Oh, we can do that, right? Yes, we can. So we're gonna go 4 equals 0. I is under max heap size. I plus plus. Boom. So now, if we go and loop through every single, what do you call it? Metadata, heap metadata, we can check if something is clear or not clear. I think. Hopefully. Okay, now. Oh, crap. No. Will that even work? You have no clue how annoying a defragment function is, dude. Is my heap just a fixed sized array on the stack? No, it's a fixed sized array, but it's on the heap. Well, I think so. I think static variables that are global are on the global variables, not static, are on the heap. Yeah, so it's just a fixed sized array. I'm gonna use mmap later. I think it's mmap, right? No? It's something like, I swear it was mmap somewhere. It was like I don't remember the actual function name. It's like, I don't know. Do I have standard lib? For what? What am I using the standard lib? Oh, no errors there. Okay, goodbye. Oh, I think I was just checking cross-referencing with Malloc a couple episodes ago. It is? Yeah, so I'll just use mmap later. But right now I'm just doing everything static because I'm already like biting off more than I can chew. I'm trying to fix the problem of fragmentation. So I already did like some magic or whatever here with like double pointers and other crap to, I guess, make defragmentation possible. Well, simply. Now that I think about it, though, No, yeah, I did everything correctly. Because then you have like the metadata, which is like this is like very, by the way, like this is obviously very not like the best way to do this, because this is just 4 times. This is 4xing your entire memory that you would allocate it. With like something like mmap, I'm pretty sure, like I never used mmap before. I just know that it exists and that's how to do it. Think you can like you like with mmap I would have done a better way to allocate. Well, oh my gosh, let me speak. Okay, with mmap I would have done a more flexible array, right? Because right now for every single metadata I have to make the arrays the exact same size as the heap, because I don't know if the user is gonna want 128 1-byte segments or 128 byte segment, right? So I can't know. But with a memmap, it's gonna be much easier, because like for most of these things, most of them are just empty, right? Like I don't even use most of them to their full capacity. The heap is used because that's literally where the data is stored. The heap pointers are not really used to their full capacity either. Most of them are just like blank or garbage data from, whatever the memory is. For metadata pointers, they're also like not used. Actually, like these are barely even used because they're just like they just like increment from the start. And also, oh yeah, also like this setup I have here, I know that it's not safe because it can still, I don't know if fragment is the right word. I don't check yet because like just give me a second to finish everything else. But I don't check for metadata pointers, which is basically just pointers that yeah. That's the thing. I like this is gonna be much more better with lists. Right now, arrays are kind of like I'm just using them for simplicity. But with lists, the problems I have with this, because the thing like these metadata this array of pointers, it just points to basically my metadata, as you can see here, is just points to a start and end. So you have like your heap and all of these, like I have the visualization here. All of these like bytes also have a metadata what do you call it? I guess not an accomplice. Like I don't know what you would call it. Like I lost the word, but it has a metadata to it, and each of them have a start and end, which point to a pointer that points to somewhere in the heap. So I can use that intermediate pointer, and I can change it if I want to like defragment this. This is just with like first of all, if you defragment and you just set a certain like a pointer of a set memory to this pointer right here, like at the start of this, for example, then you get 2 unused pointers. You get 1 unused pointer from the fact that you are changing the start of from this to this. So this pointer right here, oh crap. So this pointer right here, that's the old start, it still exists. I don't remove it. And this end this end pointer for this empty area, like just ignore this. I know I kind of picked a bad spot. And the end pointer for this empty area is switched to this because you're like merging. So you get these 2 pointers, they're just still here. They don't get removed. So like you said, like with lists and whatnot and dynamically allocated memory, all of these are gonna be fixed. But like right now it's just proof of concept. Hi guy, you miss the modding series? Okay, bro. Mod entities. I don't know if I'm gonna do Minecraft modding again. I might. Anyways, I have a project coming up that I want to do. Like it's gonna be live. It's actually gonna be like in real life. I wanna make a custom OS. I'm gonna like live stream and then make a video on it. For like a very simple custom OS from scratch for ESP32. So I don't know if I'm going to go back to Minecraft. Or anytime soon. Where were we at? Defragment. New Linux distro. Not really. It's just gonna be like pretty much all from scratch. So it's not gonna be like based on Linux. It's gonna be very simple. I just want to make it so it has a keyboard input with PS /2 or whatever you want to call it. I don't know what's called. Like the old keyboards, because they're really easy to work with. A keyboard input, maybe a mouse input later. A keyboard input, a VGA output, which I'm gonna use two ESP32s. I couldn't make it on one, but then that's way too weak because it has to like the VGA stuff. First of all, like the frame buffer will be taking up a lot of the memory, and you got like kilobytes of memory. They're not megabytes, and so it's just gonna be like a 240p 64 color. What do you call it? Thing. Outputs VGA, inputs keyboard, maybe mouse, and just make a simple console, and maybe I'll do some graphical desktop environment, simple one, and then yeah, something like that. It's gonna be like this big, and you can just like plug it in anywhere, make it run Doom. You know, like that's like not even the hardest part. Like you could probably make it run Doom, but the hardest part about that would be actually coding Doom, and I don't want to do that. Windows 3, is that a thing? Is Windows 3 a thing? Isn't that like called something else? Okay. Back to this. So what we're doing is we're going through every single metadata. And yeah. Hold on. Windows 8. If I remember correctly, is Windows 8 the one with the purple like background if you want to go into the start menu or something? I had a computer that did that. That had that for a while actually. But it was like an all-in-one computer. It was really old. It had like 2 gigabytes of RAM. I tried to play Minecraft and no, this was when I was much younger. Orange background? Oh, I don't know. Okay, heap metadata. And then max heap size. Oh, I guess not max heap size. And then we're just gonna do a couple checks. So we're gonna continue to skip until we reach an empty space. So if data dot start data flag. What happened to my renderer? Oh, my renderer still exists. I just kind of like stopped working on it. Like I could continue to work on it, but I kind of like got everything from it that I really needed. Yeah, like the render itself is pretty much finished. I added some other features like off camera, if I'm being real with you. And but yeah, it's about as good as you can get. Data flag is equal to 0, sorry. I guess doesn't equal 0. We should expect it to not equal 0. Well, okay, nice one, bro. I just kind of like removed the brackets and put them back. Then we're gonna just skip. So we're gonna do I plus equals. I think it's gonna be data start. I know I don't need these redundant brackets. Would it be no, it'd be -1, right? Whatever. What? Okay, whatever, I don't care. Sure, you can just like there you go. I meant like this. We can just cast that. Okay, and what now? Okay, that's fine. That's fine. Okay, if it is empty space, then it's just so annoying then. Then we'll do something. We'll definitely do something. guess memory address. We have to go. And like oh whoa, okay, buddy. This is like it's a bit difficult because you have to move everything, right? On the heap, and this is gonna be so annoying to do. But I guess. Oh, wait. No. What? Bald spot? Dude, this is low-key kind of annoying, though. Like here? Where's the bald spot, bro? You know, you can like scroll back on the live stream, right? Okay, and as I was saying, I guess. Oh, okay, buddy. So, dude, how do I even do this? Like, I guess I just like loop through everything. Yeah, I mean, I guess so. Int, no, whatever. For int j is equal to 0. J is under. Oh my gosh, bro. Start and end. Okay, we gotta do end. I messed up. It's actually n minus start. Yeah, I don't know what you're smoking, Felipe. I don't have braces. Hold on, but a quick question. Why am I? Oh no, no. Let's just look at that. Yo, what is this like deletion of evidence, little bro? It's literally clipped on the live stream. It's engraved into your screen. Message retracted. Mods, kill him. Okay. What? I can make you a moderator, hi guy. I can put you in timeout. I can hide you on this channel. I can go to your channel. Or I can make your channel. I can look at your channel activity. I'm tracking you. Yeah. Camera angle. Okay, so. Don't check my chat logs. It doesn't even tell me that much, if I'm being honest. Do you guys like the thumbnail, by the way? Is it fire? I'm not making them out, bro. Is the thumbnail fire? Do you guys like it? Look at this. Is it? Is this not fire? Is this fire? Is it fire? Like, be honest. No, I'm biting down on a cable. I guess I probably should have made it look better, but, you know. Also, this text is pretty fire. It's kind of annoying me, though. This little area right here. Yeah, I'm the best thumbnail designer in the West. Okay, let's go back to this. I'm not unmuted on this. Yeah, okay, this is chill. Okay, So I get. I keep sleeping. So okay, we have to just like go look at the end and then whoa. We had to assure that if end minus start is equal to. Oh no. +1. Really? What? Yo. What? Bro, what is this? Heap to metadata. Man, I'm too tired for this, bro. Oh my. Why is this Loki so difficult, bro? Like, why is this Loki so difficult, bro? We are 8 subscribers away from 600 subscribers. Can you guys believe it? I can't believe it. Okay, I'm gonna go distract myself really quick. Oh, it is raining outside. Interesting. Too bad I don't go outside. Yeah. Subscribe. Okay, yeah. We got one concurrent viewer where everybody just died. Okay. So, the way we gotta do this is very simple. So, we are. Okay. I really just want this to work. Just please. So, it's actually so different. Ow. Okay. Sorry, I just caught myself and I accidentally applied pressure on it. What an interesting stream. Maybe if I go back to modding in Minecraft and play Fawn, maybe I'll get more views. Oh, well, what am I going to do apart from programming anyways, I believe? Let's continue this project. No, you didn't miss anything. Just me having no idea as to what to do next. Bro, I swear this rain is actually it's like hypnotizing me. Check Discord general. What are we doing with our time? Is this what you were doing when you were AFK? The quality fall off is crazy. Okay, buddy. It took you that long? Okay. Bro. Why? Oh, what am I saying? Hold on. And no. You deserve to be executed after that. How about that? I'm just joking, that guy. Okay, minus heap. Wait, what's going on? What? What do you mean? Is the heap void? No. Oh, okay. So why are we doing this, bro? Neither is data.end. What? Yo, what are we even doing, bro? Try to like double dereference or something? Like, oh my gosh, bro. Oh hell no. Okay, this is. Okay, this is this, and then we dereference it once, so you get a yeah. Okay, so what's the problem, bro? I don't get like a. Okay, I'm actually going crazy, but okay, but like that's like what? Long to parameter void pointer. Where void pointer? What do you mean? What kind of void pointer? This is not a void. Okay. Dang. Dude, what are we even doing at this point? Like, what? Debugging printing? Well, I mean, this is not really a bug. This is just like this. I don't know, either me or the compiler being stupid. I don't know. Not the compiler, IDE. I think it's safe to bet that on the former. But look, I don't get this. Okay, what if like okay, what if we just do flag? Like, what's your problem, bro? Oh, it's your problem actually, sir. Because you take a void pointer, are you sure? But like, it's not a void pointer. Data. So heap plus. All that. There we go. So now, I don't like this. Are you still gonna work without it? Okay. We don't need the flag. We just need if start. Or I guess if flag. I mean, it's gonna be 0 either way, right? Equals null. Or it's gonna be the flag of 0. Okay, I know this is not the best way to do this because it's like we're doing redundant checks, but I don't care. It's a proof of concept, little bro. I'm not optimizing it. Okay, so not redundant checks. They're doing redundant calls. Yo, how good is this delay, bro? I mean, how low is this delay? Like, I say something, you guys like instantly respond. I don't even have ultra low latency on. Pirated software. Okay, I work in Blizzard, by the way. Now, what are we doing? Oh, we just. I guess no. This is it's all good, bro. We just return. It's fine. But if it's not the case, then like, okay. I guess we just, bro, this is where it gets difficult, just because it like requires brain power. I have no clue. I'm so tired. How much did I sleep today? Wait, let me recount. I have no clue either. Probably like 5 or 6 hours. That's enough, right? Okay. So we basically have to like shift everything to the left. Okay. While doesn't equal null. Yo, what have you been doing? Okay. ChatGPT? No, I know how to do this. Okay, just like give it to me. Just no, what? No, I did not. Yo, that was not it. That was a misinput. That was an actual misinput. Like, I'm not even joking. Like, I clicked the wrong button, bro. Like, that was a soundboard. Like, I actually have a soundboard. Like, it's crazy. Like, I have a soundboard for that, and that's like I clicked the wrong button. That was like AI generated. Because like, it's actually my friend that sounds like me, so that said that. So, you know, it's the AI soundboard. So let's go back and make this work. Okay, we're already checking if this is the end. If it's not the end, then guess what? We're gonna be. Okay, buddy. Okay. I just realized. Okay, we have to, first of all, we gotta shift it to the left. Then we gotta change every single pointer in the metadata. Then we gotta change every single pointer for oh, the cat's heard the food. Are you gonna jump and run for it? No, not that hungry. Okay, that works. Okay, back to this. Can I like not sit in a way where my leg is impaled by a bolt? So, actually, legitimately, we first have to do that. We have to like shift the whatchamacallit, like we gotta figure out the offset first, actually. So let's get the offset. Okay, int offset is equal to this. This means that it's an offset. What? What's up with you? Long to int. Whoa, you don't say. So, let's do this. Yo, how big is an int? For me, it's a 4 by. So, I'm just curious. How big is an int? Don't think that's true. That seems more legit. So 1 billion. Okay. So if you have more than 4 gigabytes of RAM, tough luck, bucko. Oh. Yeah. Let's go. Alright, back and forth, I guess. Okay, we're going to eat. So, this is not it, bro. Let's all calm down here. Let's figure out what we gotta do. So if that's the offset, it means we gotta switch everything to that. Man, I don't want to switch everything. I guess we just have to go through every single, like, metadata. I mean, it's not that deep, honestly. Let's just look at it. Yeah, we can just, like, we can try something. J is under. How much we gotta do? Like, man, get out of here. Like, okay, just I guess max heap size minus I. Yeah, that sounds legit. Uh-huh. Now what? Okay, now we're just gonna... They're gonna stretch. 2 hours. Oh my gosh. Has it really been 2 hours? It's been 2 hours. So now, what do we gotta do now? We gotta do something. Really. So... I guess we're just gonna go one by one, and then we're gonna check. So we're gonna get an offset. So I guess we should do. Okay, no. Plus the offset, and then if that's legit, then we're gonna move the pointers first, and then we're gonna move the data next. We're just gonna copy it, and then after that, we're gonna do. What did I say then? Like, what did I do for you to say that I'm not Sudoku idol? I'm trying to like not to trigger the YouTube thing. I don't know if they're gonna like not like that. If we go down, need to go down. So we really don't care about that. Wait, I know the meme, but like, what did I say? Because I usually like say that to people that are like, I hate the government. Oh, I just said that. Well played, hi guy. Well played. Okay. Oh, bro, I hate this. So, we're gonna go one by one. And then, okay, it's fine. It's fine. Okay, I don't know what I'm doing. Okay, sorry. Oh no, I can do that thing. It was like something like that. I don't know. True. I'm trying to see how loud I can whistle. Charlie, I'm fine. Charlie, come here. Come here. Come here. So cute. Come here. Come on the camera. Come on. Oh my gosh, look who's here. Are you gonna help me with the script, Charlie? The defragment function? Are you gonna help me with it? Yes or no? Paw reveal? Come on, let's do the paw reveal. No, he doesn't want to. He does not want to. Yo, yeah, yep, you're good, bro. You can, that's how it works. Okay, I guess we just forgot how to walk for a second there. Oh, it's so cute. So big. But it's all muscles, though. It's all muscles. It's not fat. There's no fat. It's just muscular. Okay. Wow. You know what's crazy, bro? My cast can like be stretched out like this long, bro. I'm not even joking. Allocator. That's crazy. Oh, you said something and just didn't go through. Unless I'm tripping. Did you get shadow banned? Guess we're just not live. Okay, never mind. I was wrong. Yo, I be doing anything but script, bro. Like the freedom function. Never heard the cat meow. Oh, that's refreshing. Okay, so the freedom function was easy. So why can't we do the fragment for the fragment function? I'm actually losing it, bro. It's been 2 hours of this. I'm like, bro, I'm never making a memory allocator in my life again, bro. Actually, I probably will, but like, still, this is so annoying, bro. This is not even like a good one. This is just like a regular, toy one. A good one will not have static memory, like just like statically defined at the start. A good one would be like dynamically allocated. Although for microcontrollers, I think you gotta like I don't know how the microcontrollers work. They work somehow. Okay. Anyways, back to this. What do we do? We have to get like, oh, I have to like, why is this so annoying, bro? It's gonna go, gonna move everything. Yo, I'm not joking. This is actually not it, bro. I'm not even joking. This is not it. Like, seriously, this is not it. Yeah. I don't want to do this. Okay, you know what? I'm not going to do this. Do you know why? Because I don't want to. So I'm just going to simply... Okay, buddy. Five kilobytes of memory allocated. Oh boy. Look at that. Beautiful. 6, 7. Okay, please just kill me. But how much can we go? How far can we go? What about 5 megabytes of memory? That's a whole lot of memory, guys. Okay. That's a lot of memory, though. Like, I don't even know what you would use 5 megabytes for, realistically. I mean, yeah, I know what you would use it for, but, like, I guess, like, what program needs, like, to have one array that's 5 megabytes? That's, like, a million different things. Like... Okay, 5 kilobytes is good. Let's go crazy and just allocate, like, a big one. Yo, Loki. Yo, should I do it? Should I do this? Yo, hi, yeah, yo, fully fake. Do you guys think I should just like do this? Megabyte, gigabyte, terabytes. Okay, we're gonna allocate 5 terabytes of memory. Okay, guys, we're gonna allocate 5 terabytes of memory. Ready? Is everybody ready? Oh, what happened? Dang. Guess 5 terabytes didn't work. Oh, cause it's over. We're gonna allocate 519 gigabytes of memory instead. No, this is a gigabyte. 5 gigabytes of memory. Word. This is megabytes. It's a little slower. A little slower than usual. Oh, and overflow. Okay. What if we get like a 5? Oh. No, there's no more checks? Why? Mem Alec. Plus size. Heap size. So, four, like, I want to do 6. Is over heap size, so this should work, right? No. What about this? No. -1. What? Like, bro, why? Okay, it's fine, bro. It's fine. We're gonna allocate 2 then. Yeah, we're not gonna free you, little bro. Wow. Okay, I'm just gonna save this. Should we make this a header file and I should try using it somewhere? Yeah. Okay, what should we do, guys? Like, legitimately, I don't even know what to do now. I don't really want to finish. I don't really want to continue this because, like, I'm tired. I don't know why I'm tired. Like, I generally don't know. I woke up like a couple hours ago. What's the game plan here, guys? Can I see through the mesh? Oh, I can't see through the mesh. Yeah, I'm going borderline insane. Okay, I'm just gonna probably dip now. Will I come back in the future? Maybe today. I got no clue, bro. Maybe I will. Maybe I won't. Maybe I just leave you. I don't know if I'll come back. I would want to, realistically, but we'll see. Yeah, that's about it, folks. See you next time I stream. Bye bye. Okay, I don't know what, like, this is like dragging out because like as soon as I end the stream, I'm gonna be cut off. So I gotta like drag it out so I can click the button. Okay, thank you everybody for tuning in. Oh, you're AFK. Hi, guy. Yeah, so I just like right now I just don't know what to do. Right, I don't want to continue working on defragmentation. So I'm probably gonna dip. All right. So yes, see you later, guys. I might stream later. I might stream later. I might stream later. Hi, guy. I know you're gonna be asleep, but I might stream later. I don't know. That's a maybe. Like I usually don't stream a second time, even if I say it will. Yeah. Oh yeah. Do you guys like my beer back screen? Look at that. Do you like it? I put a lot of thought and effort into it. Do you like it? I put a lot of thought and effort into it. Do you like it? Yeah, I'll stop. It's actually a pretty fire. It's pretty fire. I'm not even gonna lie. It's pretty fire. Anyways, I'm gonna probably go like a YTM just because it's trademarked. I don't know. You cannot use it anymore. I'm gonna install this table over here that I have. Oh my gosh, this weighs like a lot of. I'm gonna install this table like right next to my table. I'm gonna have two tables. And then that's what I'm gonna be doing all my electronic stuff. Are you guys gonna watch those streams? Be honest. Are you guys gonna watch those streams, the electronic streams? I'm gonna be having like my ESP32. I could probably get it right here. It's programmed to do other things right now though. Hold on. Ow. Yeah. I'm gonna get this thingy. I'm gonna make an operating system on it. It's like programmed to do it. It's a binary counter right now, so it'll just count. I am gonna sue everybody. The first person I'm gonna sue is the high guy for saying "be right back" in chat, because I actually have a trademark for it. Anyways. Yeah. I'm gonna dip now. Alright. Thank you everybody for watching, and I will see you next time. I'm just waiting, because like once again, if I click the stop stream button, I'm gonna get cut off mid-sentence. So I'm actually gonna get cut off mid-sentence.